So we're assuming that the staff is truly vertical. We're assuming that it's perpendicular to the line of collimation. But what happens if the staff is actually slightly at an angle to the vertical? The line you're reading here, the reading that you're taking, let's call that SR, is longer than the true value, let's call that ST. So when it's vertical, it gives you the true value. Anything other than the vertical is going to give you a staff reading bigger than the true value, a higher staff reading. So let's put some numbers into that. Let's take an example and say that it's 5 degrees off the vertical. So let's say the true staff reading is 1.562 and it's 5 degrees off the vertical. What we want to calculate is what the error is. So what will the staff reading be? So you can pause this video now and work it out for yourself and see if you get the same answer as the calculation I'm about to go through. So the triangle that we're looking at is like that. We know that that is 5 degrees and the adjacent is 1.562 and it's the hypotenuse that we're looking for. Let's put that like that. So we know theta, that's the adjacent, it's the hypotenuse we're looking for. So the formula we're going to use is cos theta equals adjacent over hypotenuse. So we rearrange that equation to give the hypotenuse is adjacent over cos theta. So we'll put our numbers into that, 1.562 over cos of 5 degrees, and that gives us 1.568. So the error is the difference between the true value and the reading that we're actually seeing. So the error for that 5 degree to the vertical, the error is 1.568 minus 1.562, 0.006 metres, which is 6 millimetres for a 5 millimetre error. Sorry, 5 degree error. So let's do another experiment. See what would happen if the staff was a bit more extended and you were reading further up the staff. So let's say the true value is 3.506. And again, let's say it's the same angle, 5 degrees. So we'll just put the numbers into the same formula. So hypotenuse is 3.506 over cos 5 degrees, and that comes out at 3.519. So in that situation, the same angular error of 5 degrees, the error that we're getting in the staff reading is 3.519 minus 3.506, and that's 13 millimetres. So you can see that the greater the staff reading, the greater the effect of a 5 degree error on the staff. So to minimise the effects of that error, basically we want to rock the staff through the vertical. So as it passes through the vertical, as the staff's moving backwards and forwards, the crosshair will move up and down, and as the crosshair reaches its lowest point, that is the reading that you want to take, because that is when it's closest. So that's when it's its true value. When it's at its shortest, it can't get any shorter than that.